Hello students. In this chapter, we will deep dive into Arduino Uno. That is the most commonly used development board in Arduino family. We'll also understand the pinouts and every possible detail of this board. So let's get started.
As you know from the previous lesson, Arduino is an open source electronics platform based on easy to use hardware and software. Arduino has a very robust and active community as well. In this lesson, we'll focus on the hardware side of it. Arduino.cc is the official website that also hosts comprehensive documentation and tutorial about all the Arduino products. In the hardware side of it, Arduino manufactures range of development boards with various features. The Arduino shields are the external boards that can be plugged into the Arduino for extra features. For example, if you want to add Wi-Fi capabilities to your Uno, then you can simply buy this shield and attach it to Uno. Arduino has its own programming language, which is very similar to C and C++ and quite simple to understand. We will learn about it in the next lesson. Here in the reference section, you can see all the functions provided in that language. Now let's deep dive into the Arduino Uno section. Your kit already includes one Uno, which is the most used and documented board of whole Arduino family. The Uno has Atmega 328P microcontroller as its core. Now let's look at the technical specifications of this board. The operating voltage is 5 volts and it is recommended to run it somewhere between 7 to 12 volts when you're supplying it through the lead external adapter, whereas you should not give anything lesser than 6 and anything above 20 volts. It would not even switch on at anything less than 6 and it will burn if you provide more than 20 volts. So there are 14 digital input pins. 6 also support pulse width modulation. 6 are reserved for analog inputs. Then when you're providing 5 volts, then it takes up roughly around 20 milliamps. In case of 3.3 volt, it takes 50 milliamps of current. So you have to consider this number when you are using it on battery basically. It comes with 32 kilobytes of flash memory. It is the place where your sketches are stored inside the microcontroller. It also reserves 0.5 kilobytes for bootloader. It is the program that is used by Arduino to upload your sketch into the microcontroller. Then it has 2 kilobytes of RAM and 1 KB of EPROM. EPROM is a special memory which is like a hard disk, and you can store your data permanently into that microcontroller and it would not get deleted even if you power off your microcontroller. Then it runs on 16 megahertz speed, which means it is a very small, low powered and slow processor in comparison to our computers or laptops, right? But still enough for IoT devices or microcontroller kind of a chip that is generally doing a very simple task. Now let us spend some time to understand the board that we have. We'll go through all the pins, their configurations, various components of this board, and how to make the best use of this board. We will begin with component number 1, which is a reset switch. It is utilized to restart your Uno without unplugging or detaching the power source. Whenever you feel your program is hanged, you can utilize this button to come out of that loop. Then next is ARF ref number button. Point 2 is the ARF pin, which is utilized to provide the reference voltage from outside. Point 3 is the ground pin. You can connect your external circuits to this ground. So whenever you have cases where there is a voltage calculation happening between the external circuit and the Uno, then it is a good idea to have a common ground, and hence you should connect the common ground to one of these GND pins. Then point number 4 represents the digital input output pins. They are the most important pins of this Uno, I would say. They can be configured as input and output, and in programming you can use digital read and digital write functions to read and write the values that you receive in this pin. So when we say the values, it means it is the voltage that is getting converted to digital 0 or 1. So if there is a voltage coming somewhere between 0 to, let's say, 1 volt, it would be considered as 0, digital 0, whereas anything on the higher side towards 5 volt would be considered as the high signal in digital terms. So let's say you want to switch on or switch off a bulb at your house. In your house, then in that case you would use digital input output pins, because it would represent 0 as switch off and 0 and 1 as switch on. So 1 would mean a higher voltage, which is, let's say, 5 volt. So if you connect one pin to a digital output and another pin of that LED or bulb to the ground, then when you provide 1, it would turn on, and when you provide 0, then it would turn off. Out of these 14 pins, the pin number 13 is a special one which is connected to this LED here. So if you provide 1 to pin number 13, then this LED, inbuilt LED, will start glowing, and it is often used in blink programs or as a signal in your program. Then these pins with special symbol represent PWM output pins. PWM stands for pulse width modulation. It's a special kind of a signal that is utilized for controlling motors or servos for that case. Pin numbers 0 and 1 are special pins that are used for serial communication with other external circuits. The RX and TX pins are used to connect to an external circuit whenever you want to send data serially to a sensor or a different circuit. Point number 6 is our power LED, which shows that the board is powered on. You can power your board using a USB cable connected to a computer, or via an adapter connected to this point number 13, or even a battery that you can connect to V-in pin here on this board. After you have programmed your board using USB cable, you can run it on battery. We have provided a battery holder that can accommodate 4 pencil cells. One pencil cell is of 1.5 volt, hence 4 will combine to 6 volts. That is the minimum voltage required to run your Uno. Next is a microcontroller at point number 7. It has 28 pins that are internally connected to these black pins that you see and we talked about. In fact, everything on the board is just to support programming, and your microcontroller alone is sufficient to run as a standalone circuit. Once you have programmed it, you can remove it, and once you have programmed the IC, you can remove it from the board and run it without Uno. This is called bare bones circuit. Pins highlighted in point number 8 are the analog input pins. Analog signals are different from digital signals and can attain any value between 0 and maximum voltage. This means you can provide voltage like 0.1, 2.2 and 3. These voltages can be precisely measured through analog read function. It is important to note that the parameter value for a function are these pin numbers like A0, A2 and so on. So if a sensor provides reading in analog form, then you can connect it to one of these pins. These pins have analog to digital converter circuits with 10-bit of resolution. Hence, they will map the input voltage between 0 and the operating voltage into an integer value between 0 and 1023. Next set of pins are power pins. Point number 9 is V-in. V-in is utilized to provide power from outside, like a battery source. Then there are two other ground pins, a 5 volt and a 3.3 volt output pin. Let's say you have a sensor that works on 3.3 volt. Then you can power it using this 3.3 volt and a ground pin. Point number 13 is the socket through which you can power your board using external battery source. 14 is the chip that regulates the voltage and makes sure only 5 volt is provided to the chip. Then 15 is the oscillator, which maintains 16 megahertz frequency. Then point 16 is the RX and TX LEDs, which represent the data flow whenever there is data transmission happening. They will generally be blinking. Then last is the point number 17, which is the USB Type B connector. And this is used to upload your program into the chip. This also powers your Uno. So if you have connected the board using this cable to the computer, then you need not provide any external power supply. This brings us to the end of this lesson. In the next chapter, we will install and set up Arduino IDE. I hope you have enjoyed so far, and I really appreciate for being a part of this learning journey. So, see you in the next lesson.